Okay, so it starts off by saying identify the construction shown. The first one, it shows a segment and it shows a perpendicular bisector. So the name of this is perpendicular bisector. Then the second one, it shows an angle bisector right here. So this one is angle bisector.
Wait, is it bisector through the middle?
Yes, it splits it exactly in half. Then C, they constructed an angle. Usually it's like construct a congruent angle. The way the answer keywords it is copy an angle. And the person who wrote this also wrote the exam, so I'm going to use their exact wording, copy an angle. D, it shows a line perpendicular to the given line through a point. So the way this is worded is perpendicular line through a point. And for E, it shows two parallel lines being drawn. So this is line parallel to another line through a point. Line parallel to another line through a point. So they started off with one line, they were given a point, and they drew the other line parallel to it through that point. And as you know, because we did practice constructions, it's a lot more complicated than that, but if you can just identify it, you should be all right. F, what they're doing is they're constructing a congruent triangle. Actually, F and G, they're doing the same thing. They just use a different process in both. So here they're constructing a congruent triangle using sides. So the answer is congruent triangle using sides. So by making three congruent segments, you have a congruent triangle. And then for G, they're constructing a congruent triangle, but they use side angle side. So congruent triangle using two sides and an included angle. I'm writing out the word, but if you want to use the abbreviations that we've been using, like the symbol for angle, you can. And no, we didn't practice that construction, but the exam will be multiple choice, so I think you can figure it out. What's that? Okay, ready for the next problem? I don't want to go too slow because then it gets boring too. Okay, so number one, it says the isosceles triangle shown is placed on a coordinate plane with the y-axis as its altitude. Find the length of AB, so this segment here, and the location of B if the coordinates of A are negative 3.20. Okay, so it says it's isosceles. That means this is the same distance from this y-axis here. So B must be at positive 3.20. So that's the coordinates of B that it asks for. And then it asks for the length of this segment. Well, the length would be 3.2 plus 3.2, which would equal 6.4. So the length of AB is 6.4. Okay, next one. Okay, graphing the points, and they give you coordinates. Find all possible coordinates of point D so that ABCD is a parallelogram. They already plotted A, B, and C for us, so I'm going to go ahead and sketch out like a parallelogram with one missing point. So to make this a parallelogram, I'm going to need a point over here somewhere, but I need to find the exact points. With a parallelogram, the opposite sides are congruent. So this from -1 to 5 is 6 units, so I need the top to be 6 units as well. So from 1 plus 6 would be 7 units. It would be right here. At 7, 8 to make the parallelogram. So if this was 6 units, then I knew this had to be 6 units. From 1 to 7 is where I put my point. So D would be at 7, 8. But it says find all possible coordinates. And this I didn't see at first. So there's actually another answer that it could be.
60.
Nope. The parallelogram could also go this way. Let me use like a totally different color. The parallelogram could also go this way. And again, it's 6 units at the bottom, so it needs to be 6 at the top. So it would go to -5 right here. Let's do that. Here's what we're working on. Okay, so this point here, D could be at -5, 8. So, or D could be at -5, 8. Okay, so on your desk you have half of a piece of graph paper. There are a few that we need to graph for, and number 3 is one of them. So number 3 says the vertices of triangle ABC are these 3 points. Which conclusion can be made about the angles of triangle ABC? In order to get this right, you would have to graph it out on your scratch paper. So just draw a coordinate plane. And then I'm going to plot the points. -1, -2, point A. And C. And there's my triangle. What conclusion can be made about the angles of ABC? Well, what I see is an isosceles triangle, and an isosceles triangle has congruent base angles. So angle A must be congruent to angle B. So it would be A. That's it. Okay, and then we can move to the next side. Or let's make, I'm going to make a little note. Isosceles triangles have congruent base angles. Okay, next page. Ready, Zach? Okay, number 4. Number 4 is also another graphing one. Says the coordinates of the vertices of parallelogram ABCD, and it gives us the 4 points. The slopes of which segments could be calculated to show that ABCD is a rectangle. So in order to get this one, again, I do need to graph it out. And then I'll plot the points. Okay, so I do see that it is a rectangle as it states. As far as slopes of a rectangle, I would want to see that they're like AB and BC are perpendicular. So I'd want to see that the slopes here and here are negative reciprocals of each other. So that's what I'm going to be looking for in the answer choices. So AB and DC. If I found those slopes, they would have the same slope, but that could also be just a parallelogram would have those same slopes, AB and BC. If I looked at those slopes, I would be looking for them to be negative reciprocals, and that would tell me that these lines are perpendicular, and that does make a rectangle. I could go through the rest, but it's not what I'm looking for. Number 5 is a graphing one again. Actually, I'm going to flip my paper upside down so I can just focus on the graph for 5. 5, triangle ABC has vertices and it gives us the points. The triangle may be classified as what? Well, in order to see that shape, you're going to have to graph it. Unless you have a super brain. Maybe you do. 3, 2, point B, and 0. Okay, connect the points. And what shape do we have? This is a solid 4 units. I noticed that this is definitely less than 4 units, and so is this, but these are the same measure. So it would be isosceles. Last one we're going to graph is number 6. 3 vertices of a rectangle have these coordinates. Find the coordinates of C of the 4th vertex. Okay, through the graph. I don't know if you noticed this already, but we don't really have numbers in our coordinates. What we're going to do is we're going to create like pretend numbers. So A, let's make it 3. And let's make lowercase b 2. And that'll help us with this problem. So point D is at 0, 0. And then A, I'm saying is at 3, 0. So this would be A. And say this is A, 0, which I designated as 3. D is at 0, 0. Point B is at 0, I'm saying 2, which is actually 0B. It wants to know what is point C, so that way this is a rectangle. Well, the point right here, point C would go here. That would be at A, B, the x-coordinate and the y-coordinate. That's definitely like a higher order problem. But by using fake or like pretend numbers, I could visualize it better. So C is at A, B. Okay, moving on. Number 7. Find the midpoint of line segment AB if the coordinates of A and B are A is at A0 and B is at 0B. Not another one of these. Okay, midpoint is x1 plus x2 over 2, y1 plus y2 over 2. That is not on a reference sheet. It has to be memorized. Okay, at this point, you can just plug in numbers or letters in this case. So our x for point A is A plus 0 over 2 and 0 plus B over 2. And then we can simplify it to just A over 2 and B over 2. If you get that one on the homework, you just have to kind of write it out like that or type it in like that. It's done. Okay, we're getting there, guys. Are you bored yet? Let's get through the page. Yeah. I'm boring myself at this point. Find the area and perimeter of the following figures and give correct units. Area of a triangle is 1/2 base times height. In this case, the base, it's a right triangle, the base is 3, and the height is 4. We get an area of 6 centimeters squared. It also asks for the perimeter. So perimeter is when you add up all the side lengths. So it'd be 4 plus 3 plus 5 is 12 centimeters for the perimeter. Then for the next shape, it is a rectangle. Area equals length times width for a rectangle. So area would equal 3 times 4. Area equals 12 feet squared. And yes, I'm picking up the pace because I'm losing your attention. So we're going faster. And then perimeter of this, it's showing the opposite sides are congruent. So if this is 3 feet, this is 3 feet, this is 4 feet, this is 4. So it's 3 plus 4 plus 3 plus 4. The perimeter equals 14 feet. And the last one, it's a triangle on the coordinate plane. Of course, the equation for area of a triangle is still the same, 1/2 base times height. The base here is this length, and it's from -3 to 4, so that would be 7 units. And the height is the perpendicular height from the top to the base, and that is a solid 1, 2, 3, 4 units. So area equals 1/2, the base is 7, the height's 4. Half of 28, area equals 14 units squared. Then we have to find perimeter. Perimeter is the length of all the sides added up. Here we know that this length is 7. To find the length of this side though, we have to use Pythagorean Theorem. It's 2 squared plus 4 squared equals c squared. So 4 plus 16, square root of 20. No, it's not 10 though. Square root of 20 is that length there. And then over here, 1, 2, 3, 4, 5 by 4. 5 squared plus 4 squared equals c squared. 25 plus 16 is square root of 41. So then perimeter here is 7 plus square root of 20 plus square root of 41. The answer key simplified square root of 20 to square root of 5. And then this solves out to, what did I have? 17.87. Okay, the rest are short. Okay, so this one says given rectangle DEFG, so they're telling you this is a rectangle. Determine which statements are true. Is DE equal to GF? Yes, in a rectangle opposite sides are congruent. Is EF equal to DG? Yes, it is. In a rectangle opposite sides are congruent. FL congruent to EL? Yes, diagonals of a parallelogram bisect each other, and then in a rectangle the diagonals are also congruent. So this here is the same length as this, and this is the same length as this. So EL and FL are the same length. True. Then it's asking, is triangle DLG, so this triangle here, equal to triangle FLG? Wait, am I looking at the right? I'm looking at two answers at the same time. DLG, this triangle, is that equal to ELF, this one? Yes, it is. And triangle DEG, so this entire thing, is that equal to FLG, just this part? No, that's false. And is angle DGF a right angle? It sure is. So you have true, 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 false, true. And last but not least, explain how to prove triangle MNP is congruent to ABC. We see angle, side, side, angle, side, side. We know ASS is not a congruent statement, but there was one situation when it was. And that's when you have right triangles. There's a congruent statement called, they don't call it ASS, they call it HL for hypotenuse leg. Hypotenuse leg is a congruence statement for right triangles only. So if you get the ASS congruent statement and it is a right triangle, then yes, it does work, but they don't call it ASS, they call it HL, hypotenuse leg. I wonder why. Okay, so your to-do list, you're going to have to finish the front side of this, which again is the easier side. There is an instructional video up for you to go through and fill in all the answers. And you also need to do homework number 2 on Schoology. And some of you need to go back and finish homework number 1 because y'all forgot about that last night. So you do have homework tonight. You have the last 24 minutes of class to get this done. You may actually want to fill in this exam review before you do the homeworks because the questions are on here that are on the homework and vice versa. However, as much as it's easy to just go here and pull the answer and put it onto Schoology, make sure that you're using it as a study tool and you're really thinking about how we got that answer, so that way when you see it on the exam, you'll know how to get it there too. Any questions? I'm gonna retry.